This is Biddeford High School Graduation Standard A1.2, One Variable Inequalities. As usual, let's take a look at the learning target. I can solve inequalities in one variable using a single operation. And if that sounds familiar, it's because it probably should. In our previous standard, A1.1, Solving Equations, our level 1 was I can solve equations in one variable using a single operation. So all we're doing here are we're dealing with inequalities rather than equations. Okay, I'll get set up here. Great. So the only difference between this standard and A1.1 is that instead of using an equal sign, we have four new signs we will use. On top of that, we will also add a graphing component. Great. So I know the signs you have most likely seen before, and we'll jump into those in a second, but let me just draw them here. So as I said, instead of dealing with an equal sign, we will be dealing with these four signs. And from left to right here, they are greater than, less than, greater than or equal to, and less than or equal to. Pause the video if you need more time. Let me get that back up there. Okay, so why do we do this? We previously used an equal sign to show that our variable represented a single number. So if we had, by the end of it, x equals 4 as our solution, x equals 4. So x is 4. So x is that single number which happens to be 4. Okay? So now instead of representing one number, our variable will represent multiple numbers. And if that doesn't make any sense, don't worry, we'll go over plenty of examples. Okay? Pause the video if you need more time. So let's go down here. So, this sign right here that I drew earlier. This sign is the greater than sign. Okay, and some examples are 4 is greater than 3, and x is greater than 2. Okay, and where this opens up right here, this opening will always open up towards a larger number. Always. Okay, so let's take a look at this x is greater than 2. So this means that the variable x is some number that is greater than 2. Okay, so if this were an equal sign, it would say x equals 2, so x would be 2, the single number 2. Okay, in this case, x is greater than 2. So just think about it for a second. What are some numbers that x can be? Well, x can be any number that's greater than 2, so x could be 3, 4, 5, 100, a million, any of those numbers, as long as it is greater than 2. If it equals 2, this statement would not be true, because 2 is not greater than 2. Okay? So as I said, x can be any number that is greater than 2. Alright, so here we have the less than sign. Okay, so some examples. 1 is less than 100, let's say. And let's put w is less than 6. So this statement over here tells us that the variable w is some number that is less than 6. Okay? So again, some numbers that w could be 5, 4, 3, 2, 1, 0, or any negative number, because all of those numbers are less than 6. Great. Moving on. Okay. Sign number 3, we have greater than or equal to, which looks just like our greater than symbol, except it has a line beneath it. Okay. So some examples here. 10 is greater than or equal to 4. I'm also going to write this example here. 1 is greater than or equal to 1. Okay, so both of these are true. Because 10 is greater than or equal to to 4, while 1 is also greater than or actually those are a little close. Let me step right in there. Or equal to 1. Okay? So really we have two conditions here for greater than or equal to. So if the symbol is used, the greater than or equal to symbol, okay, this number has to be greater than or equal to. So it can be greater, so 10 is greater than 4, so this statement is true. But the reason this 1 is greater than or equal to 1 statement is true is because 1 is not greater than 1, but it is equal to 1. Therefore, our equation has been satisfied. Okay. Pause if you need more time. Okay. And last but not least, we have the less than or equal to sign. Okay. So some examples are -1 is less than or equal to 0. And same as our last situation, I'm going to put 5 is less than or equal to 5. So these are both true. Because -1 is less than or equal to 0. While 5 is less than or equal to 5. So same reasoning as our last situation. -1 satisfies the less than component of this sign. So -1 is less than 0. 5 is not less than 5, but 5 is equal to 5. And since we have two conditions here, this statement is true. Alright, so some quick things to remember here as we move forward. So we're going to go over some properties. So we're going to solve these equations the same exact way as we did in A1.1. Okay? So let's just recall those operations that we used. So remember that addition can undo subtraction. Okay? I'm going to draw an arrow right here because addition can undo subtraction, but also subtraction can undo addition. Okay? Our other one, multiplication can undo division, and vice versa. So let me draw those arrows. Okay, and this last one here, we're not going to deal with it during this standard, but I think it's important that it's introduced as early as possible. So I'll put radicals can undo exponents. which we will see later in the year, actually towards summer break, in standard A5, which goes over exponents in detail. Okay, but for now, there's no harm in having this statement here as well. All right, so let's look at some examples. So it's important for these examples to know that we are solving them the same exact way as we did in A1.1, except instead of an equal sign, we have these signs right here. Okay, greater than, less than, greater than or equal to, and less than or equal to. So what I'm going to do to solve this one, I'm going to use the exact same process. So I'll make my t. Okay, I'll subtract 7 on both sides to get the c by itself. So I have c, and then negative 12 minus 7 is negative 19. So what sign am I going to put here? I'm not going to put an equal sign, but instead I'm just going to drop this sign straight down. So c is greater than negative 19. Okay, so c isn't negative 19. C does not equal negative 19. That is false. But c is greater than negative 19. So c can be negative 18, negative 17, 0, 1, 5, 100, a million. Doesn't matter. Okay? So here we have a true statement. Okay? Let's go right over here. So I'll make my t. We are not done with those. I'll add 2 on this side to get the c by itself. I'll add 2 on this side. So I have c and 7. I'll drop down my greater than sign. So c is greater than 7. So c could be 8, 9, 10, 100, 1,000, 5,000. Doesn't matter. Okay? C is greater than 7. Okay? Moving on to this one. I'll make my t. Divide by 9 on both sides to get the b by itself. So 9's cancel. So I'm left with b is less than or equal to 4 over 9. Now, as I've said previously, it's okay to have improper fractions as our answer. Okay. In this example right here, we have a fraction multiplied by our variable. So I'll multiply by 6 on this side, multiply by 6 on this side. Our 6's cancel, so I'm left with d is less than 18. Okay, so those shouldn't be too mind-blowing right now. Pretty much what we've already done, except instead of dropping down an equal sign, we're just dropping down whatever symbol we are given. Okay, pause the video if you need more time. So as I mentioned earlier, we are going to add a graphing component in this standard. Okay? So we'll get into that right now. So if we have one variable, we can graph our solutions using a number line. Okay. So whenever we see work, or we have practice, or formative assessments, summative assessments, the number line down below isn't optional. Okay? That's half the solution. Okay? So by using the number line, we're proving that we know that our variable isn't equal to a single number, it's equal to multiple numbers. Okay? So if the sign in our final answer is greater than or less than, we graph our point using an open circle. Again, if that makes no sense to you right now, we'll look at some examples. Okay? And if the sign in our final answer is greater than or equal to, or less than or equal to, we graph our point using a closed circle. Okay, pause the video if you need more time. So here's some more level 1 examples. So I'm going to solve them the same exact way. So I have negative 2 plus a is greater than or equal to 9. So I'll make my t. I'll add 2 on this side to get rid of this negative 2. I'll add 2 on this side. So I'm left with a is greater than or equal to 9 plus 2, which is 11. Okay, so there's one half of my solution right there. I did the algebraic part, we'll call it. Okay, so now I need the graphing part of this. So what I'm going to do, I'll go right over here and I'll make this middle notch 11. So I'll draw a little circle. And if we go back up in our notes, we see that if we are using a greater than or equal to symbol or a less than or equal to symbol, we used a closed circle. So all that means is I'm going to go back over here to this little circle I made. I'm just going to color it in. This colored in circle means that our solution is included. So a is greater than or equal to 11. That means a could be 11. Okay? It could also be any number that is greater than 11. Okay? So let's make some marks here. I'll say this is 11, 12, put 13 right here. I'll go back here to 9. As long as you can demonstrate you know how this number line works, I don't care if you label every single notch, every other notch, every third notch, doesn't matter. As long as we have 3 numbers here. Okay, so we have a is greater than or equal to 11. So what I'm going to say to myself, could a be 10? Is 10 greater than or equal to 11? No, it's not. What about 12? Is 12 greater than or equal to 11? Yes, it is. So I'm just going to put a little X here to know that all the answers on this end of the number line are false. Okay? So I'm going to draw over top of my line here and extend my arrow past this arrow here just to show that I know a is any number that is greater than or equal to 11. So that means all of these numbers on this side of the number line. Okay, so let's go to this next one. I have x divided by 10, so I'm going to multiply by 10 on both sides. Okay, 10's cancel. I'm left with x is greater than 160. Okay, so I'll go back here, I'll draw a circle, mark some points, so 160, put 162 right here, and I'll put 158 back here. Okay, so I'll go to 159. Is 159 greater than 160? No. So it can't be any numbers on this side of the number line. What about this side? Go to 161. Is 161 greater than 160? Yes. So it'll be all solutions on this side of the number line. Okay? And I'll leave my circle open because 160 is not included. Okay? 160 is not greater than 160. Okay? Perfect. Let's do the last one. Make my t. Okay? So 4 times a. That's what I'll do. So I'll divide by 4 on both sides. So I'm left with a is greater than or equal to negative 7. Awesome. So, I'll draw a little circle over here. Mark my points, negative 7. Be careful with negative numbers because our values get lower as we go greater. And what I mean by that, negative 6 would be to the right side, negative 5 would be to the right side, negative 4 would be to the right side. Whereas negative 8 would be on this side, negative 9 would be on this side, negative 11, negative 100. Just be careful. That's all I'm trying to say. Okay? So we have a greater than or equal to sign. So I'm going to color this circle in because negative 7 is included. Okay? So I'll go to negative 8. Is negative 8 greater than or equal to negative 7? No, it's not. So I'll draw a little X here. And again, you don't have to put this X. It just helps me visualize what's going on. Okay? So I'll go to negative 6. Is negative 6 greater than or equal to negative 7? It sure is. So I'll draw a line right there. These would be acceptable solutions on any practice or assessment that we take in the future. Great. Pause the video if you need more time. Okay, so let's go to level 2. So learning target here. Very similar to level 2 in A1.1 solving equations. I can solve inequalities using 2 different operations. Okay, so only difference between level 2 and this standard and the last standard, we replace this word inequalities with equations. So we're going to follow the same process. The only difference is we have our 4 signs, our 4 new ones, and we have the graphing component. Okay? Okay, so let's get to it. Make my t. I have negative 7 over here, so I'll add 7 to get rid of it. I'll add 7 over here. So I have r divided by 4 is greater than or equal to negative 9 plus 7 is negative 2. Okay, run out of room, so I'll go right up here. I'll multiply by 4 on both sides. So our 4's cancel. So I have the r by itself. So r is greater than or equal to negative 2 times 4, which is negative 8. Okay, so let me go graph this. I'll draw a circle down here. I have a greater than or equal to sign, so I'll color it in because negative 8's included. You make some points down here. Negative 6 over here. I'll put negative 10 over here. Okay. So I'll go to negative 9. Is negative 9 greater than or equal to negative 8? No, it's not. So I'll put a little X. Okay. What about negative 7? Is negative 7 greater than or equal to negative 8? It sure is. So draw a line over top of my number line, and there we have a final answer. Okay. Go over to this one, make my t. I need to get rid of this negative 3, so I'll add 3 on both sides. So I'm left with 4c is greater than or equal to 14. So I'll make another t. I'll divide by 4 to get this c by itself because they're being multiplied. So I'm left with c is greater than or equal to 14 over 4. I'll leave that as an improper fraction, but I'll simplify it. So 14 and 4 are both divisible by 2, so I'll leave this as 7 over 2. Okay, so I'll draw my circle. It's greater than or equal to, so I'll color it in. 7 over 2 is included. So if you type 7 over 2 into a calculator, you'll see the answer is 3.5. 3.5. Okay, so I'll have 7 over 2 over here, so I'll put 4 over here, because that's greater than 3.5, and I'll put 3 back here. Okay, again, it doesn't matter which numbers you choose here, as long as you're proving that one number is less than 7 over 2 and one number is greater than 7 over 2. You can have many different solutions. Okay, so I have greater than or equal to. So is 4 greater than or equal to 7 over 2? It is, so I'll go this way. Which means our solution can't come from this end of the number line. Okay, here we go. Having trouble over here. Okay. So I b minus 2 divided by 5 is less than 2, so I'll multiply by 5 on both sides. 5's cancel, so I have b minus 2 is less than 10. I'll draw my t. I'll add 2 on both sides. So I'm left with b is less than 12. Okay, so I'll make my circle. I'll put a 12 here. I'll go 14, and I'll go 10. Okay, so would 13 work? Is 13 less than 12? No, it's not. So we'll put an X up here. What about 11? Is 11 less than 12? It is. So I'll draw my line this way. Okay, go over to this one, make my t. Positive 7 being added, so I'll subtract 7 on both sides. So I'm left with 2c is greater than or equal to 9 minus 7, which is 2. So to get that c by itself, I'll divide by 2 on both sides. So 2 divided by 2, that's 1. I have greater than or equal to, and I'm left with c. So my solution is c. It could be any number that is greater than or equal to 1. So again, I'm going to have a closed circle because 1 is included. Put 1, I'll put 3, and I'll put negative 1. Okay, so c is any number that is greater than or equal to 1. So my solution cannot come from this part of the number line. Okay, moving on. I know we're going through these fast, but by this point we've already had a lot of practice solving one variable equations. These aren't much different. Okay, so if you need more practice with these, maybe check out the A1.1 level 1, 2, or 3 video. Okay, so these 6's cancel. I have b plus 3 is less than 8 times 6, which is 48. Draw my t. Subtract 3 on both sides. So I have b is less than 45. So let's go to the number line. I have an open circle right here because 45 is not included. You label some lines, 45, 47, and 43. Okay, so 46 could not be a solution because 46 is not less than 45. So I'll draw a little X. And my line will be pointing this way towards all of these solutions. Great, last one. Okay, save the hardest for last. So I know my first step, I can add 5 to both sides. So I have 2/3 d is greater than 9. Okay? So at this point we've only dealt with fractions that have had a 1 in the numerator. Here we have a 2. Okay? So we know that if we had a fraction where if we had 1 over 3, we could multiply by 3 on both sides, and the d would be by itself. So because of that, I'll put multiplied by 3 on both sides. We also knew that if we had 2 times d, 2 and d being multiplied together, we would get rid of that 2 by dividing by 2. So I'll write that as well. Okay, so our 2's cancel, and our 3's cancel. Okay, so I'm left with d is greater than 9 times 3 is 27. Remember, we just multiply the numerators. And I'm left with 2 in the denominator. Okay, so I'll make my circle. It's an open circle because it's just a greater than sign. Okay, so I'll put 27 over 2. So if you plug 27 over 2 into a calculator, we realize that it is right in between 14 and 13. It's 13 and a half. So I'll put 14 over here, and I'll put 13 over here. Okay, so d is greater than 27 over 2. So our solution won't come from this portion of the number line. It will come from this portion. Okay, so at this point, please complete some level 2 practice, and if that goes well, you should be ready for a level 2 formative.